Okay, let's get started on this 1.2 homework. All right, so find the expressions for the quadratic functions whose graphs are shown below. So we've got two of them here. Let me bring up my little editor. All right, so a couple of things to notice here. First of all, we have 2 points given to us. One point is the point 80. That happens to be our vertex. And then we have another point here, which is just like an x and a y coordinate. So let's first talk about quadratic functions. This one is f. So we know that all parabolas can be written a times x minus h squared plus k, where h and k are the vertex. H and k are the coordinates of the vertex. So this is really our h, and this right here is our k. So far, here's what I can tell you. This parabola looks like this: x minus 8 squared plus nothing. And then to find a, what I'm going to do is I'm going to use the fact that this equation, which I'm going to replace fx with y, must be true when I plug in 9 for x and 2 for y. So if I plug in 2 here, leave my a alone, plug in x is 9, this should be true. So 9 minus 8 is 1, 1 squared is 1, 1 times a is a. So that means that a is 2. So coming back up here, I can write f of x equals a, which is 2, x minus 8 squared. So that is the equation of that parabola right there. All right, now we're going to take a look at the next one. Let me clear this out. Okay, this one I'm actually given 3 points, but I'm not given the vertex. So this one's going to be a little more involved. First of all, I know my g function can be written as a x minus h squared plus k. That's one way to write it, and that's the best way to write it if we know what h and k are. If we don't know what h and k are, then we know that that can be written in a different form. So that's also a way it can be written. If I can just figure out what a, b, and c are, I'd have the equation of the parabola. So let's first use this point negative 2, 2. Again, that means when I plug in negative 2 for x, I should get 2 out for y. Replacing the g of x with y, we get y equals ax squared plus bx plus c. Now I'm going to be using that for the rest of the problem. Let me first plug in negative 2 for x and 2 for y. I'm going to write it down over here. We have 2 equals a times x squared. X is negative 2 squared is 4, so 4a, plus b times x, but x is negative 2, so b times negative 2 is negative 2b, and then plus c. So that's the first thing. That's what I get when I plug in this point. I get that equation. So I have one equation right now, and I have 3 unknowns. Now let me use this one, okay? So I know that 1 comes out when I plug in 0 for x. Well, plugging in 0 for x here, I get nothing here, nothing here. That means all I get is c. So c must be 1. And then the last equation says that I have negative 2.5 come out when I plug in 1 for x. So if I plug in 1 for x, I get a plus b plus c. So what I have now are 3 equations, and I actually know what c is, so I can replace the c with 1. So let me take this system of equations. Let me replace the c here with 1, and this c with 1. I'm going to move the 1 over by subtracting it on both sides of those equations. I'm not using that anymore. The first equation becomes 4a minus 2b equals 1 because I subtracted 1 on both sides. The next one, I get a plus b equals negative 3.5 because I subtracted 1 on both sides. And now what I need to do is solve this system of equations. And there's different ways to do it. You can use elimination or substitution. I'm going to use substitution, which means I'm just going to solve this first equation for a, which means I'm going to move b to the other side, make it minus b over here. It's gone. So I know that a must be equal to negative 3.5 minus b. So rewriting the first equation, replacing A with negative 3.5 minus B, I get 4 times negative 3.5 minus B. Then minus 2B must be 1. Now this equation only has B in it. I multiply through here. 4 times negative 3.5 is negative, 14. And then 4 times negative B is negative 4B. And then I have minus 2B must equal 1. Let me move things around here. Subtract or put these two together here. We get negative 6B. I'm going to add 14 to both sides, which gives me 15. And that means B is equal to negative 15 over 6, which reduces, 3 goes into both of those, negative 5 over 2. And now that I know what that is, I take my equation I had for A here. Remember, A was equal to negative 3.5 minus B. I replace my B with negative 5/2, or negative 2.5. Let's do negative 2.5. A is equal to negative 6. So what we get, I'm trying to squeeze this all in here, is that my function g has to be a, which is negative 6, x squared, plus b, which is negative 5/2 x, plus c, which is 1. So that is the equation of this parabola. Now let's see if their solution worked the same way, if they did it the same way. They may have used elimination instead of substitution. Let's see. Nope. Let's see here. We have an issue. Where's my issue on this? Bring this back in here. Negative 6. Trying to see where there seems to be a little bit of an issue. Negative 5/2. Bring that solution back up. They're saying we should have a negative. A should be negative 1. 4a minus 2b equals 1. 4a minus 2b equals 1. No, this looks right. Oh, I see it. Apologize. This should be a plus right here. That should be a plus. And the reason why is because I'm supposed to plug in minus b here. That's minus a negative. Oops. So that should be plus. And since you add, you get negative 1 here instead. So change that to a negative 1. Yeah. Hey, we all make mistakes. Okay, that's it for that one. And now, next problem. That was the first one. Wait a minute. Okay, second one here. If the recommended adult dosage for a drug is D in milligrams, then determine the appropriate dosage C for a child of age A. This is what pharmacists use. So here we go. Suppose the dosage for an adult is 100 milligrams. Find the slope of the graph of C. So what is the slope of the graph of C? Well, if we put 100 in here, multiply by 100, that means we're going to move this put 100 here and multiply that by 100, which moves the decimal point 2 places. We get 4.17, and that's the number in front of A. So that's our slope. So 4.17 here. Okay, what does the slope represent? Well, it represents the change in milligrams or the amount total. Well, C is the dosage for a child, right? So the slope of this line is going to be the rate of change of that dosage, so it's change in milligrams. And then what is the dosage of a newborn? So round off your answer. So dosage for a newborn, we have to assume age A is 0. And if age A is 0, then the dosage will be exactly 0 plus 1, which is 1, and then times 100 times this, which will be 4.17. So let's see. Here we go. So 100 in there. This is your slope. It's 4.17. Slope is going to be the rate of change of the dosage. Newborn A is 0, so there's your result. All right. All right. So graph the function by hand, not plotting points, starting with the graph of one of the standard functions, and then use the appropriate transformations. So for this, what we're going to do, clear this out, what we're going to do here is start off with a graph of something we know. So we should all be comfortable with y equals 1 over x. Y equals 1 over x looks like this. We have horizontal asymptote here. We have vertical asymptote like this. And then so the question becomes, what happens if you just add 5? Well, if you add 5 down here next to x, it has the effect of moving the graph either left or right. And remember from college algebra, whenever you do transformations of functions, if you add a number outside like this, add 5 out here, it moves things up and down. But if you add them inside the function like this plus 5 is, it moves them left or right. And it actually goes opposite of what you would think. So instead of going to the right 5, you're actually going to move this graph right here to the left 5, which should not look like this. It should be right here, this one. All right. Now, that's what they're just saying here. Move it to the left 5. Okay, graph this by hand. So here's a square root function. Square root functions look like this. Square root function, basic square root function. Looks like that. And what we're going to do is we're going to subtract a 2 inside, which is going to have the effect of moving it to the right 2, opposite of what we think. And then we're going to move it, minus 1 means down 1. So we want to take this graph, move it to the right 2, and then down 1. So something like that. So it looks like it's this one right here. Let's just double check these. Yeah, this one went to the right 2, up 1. We don't want that. This one went to the left 2, down 1. We don't want that. So it's this one right here. Okay, next one. For each of the following functions, add them. All right, so this is just computational stuff here. Okay, let me start with this one. If I add these two functions together, all I do is just put them like this. And you can't add square roots unless what's underneath them is exactly the same. So I'm just going to leave it. The domain of the function, well, we got to make sure that both of these are never negative numbers. So I need 2 minus x to be greater than or equal to 0, which means 2 is greater than or equal to x by adding x on both sides. So on a number line, here's 2. I can be 2, and I can be anything to the left of 2. And then the other one I have to look at is the x squared plus 1. X squared, minus 1. That must be greater than or equal to 0. So I turn it into an equation first, x squared minus 1 equals 0. I get two solutions, x is negative 1 and positive 1. I go back to that whole idea that, you know, at negative 1 and positive 1, I have 0, and then it's a parabola, right? This is a parabola that opens up, so it looks like that, and I want to know when it's positive, so that's going to be over here and over here. So what I need to do is figure out where both of these overlap, and it looks like it would overlap. Let's see, 2 is out here, so I include 2. It'll be everything in between here, and then everything over here would work also forever. So it looks like negative infinity to negative 1 I can include -1 unioned with 1 to 2, but nothing past 2. Okay, next thing. That was a domain there. What's f minus g? So if I do f minus g, the only difference is subtraction between them. And nothing in the domain changes because we still have the same conditions as far as what we need to keep those from being negative underneath. So we have the same domain. All right, and now let's look at fg, which is the product. So if I take this times this, then what we can do is we can put them both underneath the square root. This. That. And then you can multiply that all out. As far as domain, though, we need to pay some attention because it's possible now that the domain's going to change. Just because what's under here is negative, that's if this right here is negative, that's no good if we look at it right here by itself. But when it's multiplied times this next to it, what if that's negative also? Then they both multiply together to be positive. So let's go ahead and expand this out. We get 2x squared. We get minus 2. We get minus x cubed, and then we get plus x, like that. Or if better yet, if you like, you know what, let's do this instead. I think this will make it a little easier to understand. Let's do it this way. Let's take that difference of squares and factor it. This will be easier. What we need to make sure is that everything under here is bigger than or equal to 0. So what we're going to first do, like we've done before, like we did up here, is we're going to figure out where it is equal to 0. So where is that equal to 0? Well, when is 2 minus x, x plus 1, x minus 1 equal to 0? We'll set each of those equal to 0. You get 2, negative 1, positive 1. So now I need more room. Let me do this. Clear some of this out of here. Okay, so if I'm looking at a number line, I know that this thing is 0 at negative 1, at 1, and at 2. So those points are okay to have because on those points I'm equal to 0. I can take the square root of 0. That's fine. But to figure out the rest of what's happening, I need to figure out what's happening in each of these separate regions. Now, there's several ways to do this. We could test some points, right? Or you could just use what you know about polynomials and the graphs of polynomials. Like before, up here, we knew we had a quadratic. It looked like that. We had 2 x-intercepts. Here, if you know what this looks like, then you can graph it. I'm going to just do test points. So I'm just going to pick, let's say, negative 2. I'm going to pick 0. I'm going to pick 1.5, and I'm going to pick 3. And I'm just going to plug them in right here and see if I get something that works. So if I plug in negative 2, what would happen if I plug in negative 2 right in here? I get 2 minus negative 2, which is 2 plus 2, so I get 4. And then negative 2 plus 1 is negative 1. And then negative 2 minus 1 is negative 3. If we multiply those all together, you get a positive number. So this works over here. If I plug in 0, see, if I plug in 0, I get 2, 1, and then negative 1. That won't work because that gives me a negative number. If I plug in 1.5, I get 0.5, 2.5, and then 0.5. And multiply all those together, it does work. And then this one, if I plug in 3, you can check it for yourself. That won't work. So I can have everything over here and everything in between. So I say that negative infinity all the way to negative 1, union with 1 to 2. And remember, we do include the endpoints because that makes it 0, and it's okay to have the square root of 0. All right. Let's see. Where are we? f minus g. I think I'm going to clear this all out. Okay, how about division? So when we divide these two, and I think I'll just do it up here. Oh wait, which one was it? F over g? Okay, if I do f over g, square root 2 minus x over square root x squared minus 1, then we can turn that into single root 2x minus, or 2 minus x, and then here we can say x plus 1, x minus 1. And I know that this thing is going to be undefined whenever I get 1 or negative 1. So if I do a number line, here's negative 1, here's 1. Oh, that's not 1, that's a 0. And then at 2, if x is 2, I get 0 up here. 0 divided by that, it's going to be 0. So I can have 0 under the root. I just can't have division by 0, so I do not want to include these. And then what you could do is, like before, you could do like test points and check these out, and you should get the same results you had earlier. You should have yes, no, yes, and no. So you should get negative infinity this time to negative 1. Do not include negative 1. Union with everything between 1 and 2. Include 1. I mean, don't include 1, but include 2. So slight difference between those two domains on parts C and D. All right. Okay, let's see what they have here. Check this out. Yeah. Okay. So what do they do here? They don't really show you too much, do they? But you can see it's the same result we had. All right, next one. For each of the following, find some composition. So this is, again, just some review of algebra. Okay, f of g of x. So that means I'm going to take f. Inside of it, I'm going to plug in g. So that means I'm going to take f, and I'm going to plug in g, which is 4x minus 1, or plus 1, which means I'm going to take 4x plus 1 and plug it in right here for x. So that means I have 4x plus 1 squared and then minus 5. And then you can continue that. You have to just FOIL that out. Domain, well, it's a polynomial, so everything is going to be well defined. So domain should be all real numbers. G of f, we go backwards. We take g and inside we put f. That means we take g and we put inside of it x squared minus 5, which means we take the x here in g and we replace it with this. So we have 4 times x squared minus 5 and then plus 1. And go ahead and distribute through and collect like terms. Again, domain should be all real numbers because it's a nice, well-defined polynomial. All right, f of f. This one's interesting. I'm going to take f, and inside I'm going to plug f, which means I'm going to take f, and inside I'm going to plug x squared minus 5. And that means x squared minus 5 is going to get plugged in right here to this x. So I'm going to take x squared minus 5, and I'm going to square it minus 5. And then you could expand that out, multiply everything out, collect like terms, and get your answer. I will not do more. Let's see, domain is a polynomial. So it's a polynomial, so domain is all real numbers. So there's more work to do on those, but hopefully you get the idea. Let's see what else we've got here. G of g. G of g, 4x plus 1. Okay, so that means I'm going to do g and inside g, which means g and inside that 4x plus 1. But that means I'm going to take 4 times 4x plus 1 and then plus 1, and then distribute through and collect like terms. Domain, again, all real numbers. All right. Now this one's going to be a little more interesting. All right, for this one, let's figure out what f of g of x is. So I'm going to take f, and inside of it, I'm plug g. Okay. And then, from that, I plug that into f. So this part here is going to go right in for x there and x there. So I have x plus 8 over x plus 2 plus 1 over this fraction. All right, 1 over x is well, if x is this, then it's 1 over a fraction, so it's just the reciprocal. So I just flip it over. X plus 2 over x plus 8. Like that. The domain of this, okay, the domain of this, you have to be a little careful with your domains here, because what's happening is x is first going into g and then going into f. So what can you not plug into g? Well, look at g. You can't plug in -2, right? -2 cannot go in there. And that you can tell from here. You know, x cannot be -2. But then you also need to make sure that that whatever you plug in, right, here, whatever comes through here, we got to make sure that 0 does not come out here. Because if we do that, we get a 0 here, and it's division by 0. So what would make this g function spit out a 0? Well, that would happen if x is equal to -8. And you can see that actually is here also if x is -8. So we have two things. X cannot be -2 and x cannot be -8. So everything except those two numbers. Now let's try and do this the other way. Let's go g of f. So g of f, we start with g. Start with g, and inside of it we put f, x plus 1 over x, which is, when we plug that into g, we get x plus 1 over x, then plus 8, that's on top, and then on bottom, x plus 1 over x plus 2. And I think it's obvious, hopefully, from this that x cannot be 0. If x is not 0, if x is 0, then we have division by 0. But then we also need to make sure that this down here is never 0, right? We can't have division by 0. So how can we be sure that that's never going to be 0? Well, let's just write that out. X plus 1 over x. Let's figure out when it is 0. When is that 0? We'll multiply everything by x. That's not a 1. That's not an x. That's a 1. Right, multiply this by x, get x squared. Multiply this by x, get 1. Multiply this by x, get 2x. Multiply 0 by x, I get 0. This is x squared plus 2x plus 1 equals 0. But that factors x plus 1 times x plus 1 equals 0. So take square root of both sides, which means x is equal to -1. So if x is -1, I appear to have a problem also. So x cannot be -1. Let's just look at it. Again, remembering that x is going to go in, it's going to go into f, and then it's going to come out and go into g. So let's just try and plug in -1. If I plug -1 in here for f, I get -1 plus 1 over -1. That's the same as -2. Now take -2 and try and plug it in here. And you can't. You get division by 0. So you can see that this is, our domain is everything except those two numbers. All right, f of f. And then g of g. And man, there's still a lot of homework here. All right. F of f, g of g. I think I'm going to leave those to you. I think you got the idea here. Okay, for this one, let's try and figure out what f of g of h is. Okay, so I'm going to go f, and inside of that, I'm going to go g, and inside of that, I'm going to go h of x. All right, so this is f, inside of that is g, and inside of that is h. H is cube root of x. And then what happens if I take the cube root of x and plug it into g? So I'm going to put cube root of x there, cube root of x there. So I get cube root of x over cube root of x minus 5. And now what if I take all of that and plug that into f? Well, it's just the tangent function. So tangent of cube root of x over cube root of x minus 5. That's our composition right there. So that's just showing you how you take a function, plug it into a function, then take that and plug it into a function. Okay, next thing. Now what we're doing is working backwards. This is real important. Okay, express the function in the form f of g of x. So the way we're going to do this is that we want this to be f with g plugged inside. We've got to figure out what capital F is this. But we want to see this here, capital F, as being a function inside of a function. So I think you can see that this 9x plus x squared is inside something to the fourth power. So if we let little f be equal to x to the fourth power, and we let g be equal to the 9x plus x to the x squared, then if I take g and plug it into f, which is what we're supposed to do, then what we'll get is 9x plus x squared all raised to the fourth. So this should be the f that makes that happen. Okay. Another one of these. All right. We want to treat g as cosecant t, and we want to look at the u here as being f of g of t. So if this in here is going to be my g, and this is my g, then my little f of t should be, I need that g to be up there, so I'm going to replace that t with g. Then 8 plus, I'm going to replace that t right there with g. And now if g of t is cosecant t, you can see that when I take this and plug it in here and here, that means I'm doing this composition, I should get out this u of t. Okay, same thing here. Express the function in the form f of g of h. This time there's 3 functions. F is x to the 6th. H is square root of x. So we're trying to find the function in the middle. Trying to find this middle one. So you can see that we've got the x to the 6th here. You can see that we've got the h here. The function that's missing is the sign. So let's just try that. What if g of x is sine x? Now h of x, they said, was square root of x. And f of x was x to the 6th. So what happens if I take h and plug it in here into g? I get sine of square root of x. Now what if I take that and I plug it in here for x? Then I get sine square root of x to the 6th power, which is exactly the same. Notation-wise, it means the exact same thing as this. So that's what I was going for. So our answer here was sine x. G of x should be sine x. Okay, given the graphs of f and g, evaluate each expression or say it's undefined. All right, let's look at this first one here. All right, I want g. What's g of 2? Well, okay, here's g and here's f. So g of 2, I go out 2, I go up, I get this value here, which is 1, 2, 3, 4, 5. 5. So g of 2 is a 5, and I'm plugging that into f. So what's f of 5? 1, 2, 3, 4, 5. 1, 2, 3, 4. So I get 4 out. All right, let's go f of 0. So I go to 0 on the f function, which is this one. F of 0, well, it is 0. So that's 0, and I'm plugging that into g. What's g of 0? Well, g of 0 is 1, 2, 3 up here. So this should be 3. All right, now let's do f of g of 0. That's the same as f of g of 0. So first thing, what's g of 0? G of 0 is 1, 2, 3. So this is a 3. And now that goes into f. So what's f of 3? 1, 2, 3. Up. Comes out to be 0. All right. Let's see what else they got here for us. I'm going to need the graph to do this. Let's see if I can make this a little bigger. Okay, let's do this one here. All right. What's g of f of 6? Okay, so let me find f of 6 first. 1, 2, 3, 4, 5, 6. Great, it's off my graph. I need the whole graph, of course. 1, 2, 3, 4, 5, 6. Go up 1, 2, 3, 4, 5, 6. So it looks like it's 6. So this is 6. So this is the same as g of 6. And what's g of 6? 1, 2, 3, 4, 5. Wait. 1, 2, 3, 4, 5, 6. G. Wait, my g is not here. This is undefined. There is no g doesn't exist out there, so it's undefined. How about g of 2? So g of 2, oh, negative 2. Okay, what's g of negative 2? 1, 2, that's negative 2. That's up there at 1, so that's a 1 inside there. So g of 1, what's g of 1? 1, well, go up 1, 2, 3, 4. So it looks like 4 comes out. So this is 4. What's f of 4? It's kind of cut off there on the bottom of the page. Well, first, what's f of 4? 1, 2, 3, 4, 1, 2. So f of 4 is 2. What's f of 2? 1, 2. Well, it's negative 2. I think there's one more down there. No, that was it. Okay. Okay, a spherical balloon is being inflated, and the radius of the balloon is increasing at a rate of 4 centimeters per second. Express the radius of the balloon as a function of time. All right. So what is the radius of the balloon doing as a function of time? Every second, it is increasing by 4 centimeters. So my radius, the radius as a function of time is 4. Okay, 4 times t. Okay, that's the radius. It says a spherical balloon is being inflated, and the radius of the balloon is increasing at a rate of 4 centimeters per second. Express the radius of the balloon as a function of time. So we know that the radius of the balloon, we're assuming at 0, it's 0, and then 1 second later, it's 4 centimeters. 2 seconds later, it should be 8. 3 seconds later, it should be 12 centimeters, so on and so forth. So this is our rate of change. If V is the volume of the balloon, right? If V is the volume of the balloon as a function of the radius, find V of R. So what is the volume of a balloon? Volume, what is the volume of a sphere? 4/3 pi r cubed. All right, that's the volume of a sphere. And so the radius here, right, is a function of time, which is 4t. So what I need to do is I need to replace the r with 4t. And so you get 4/3 pi times 4t cubed. And then you just, raise 4 to the 3rd power, 64, and then t cubed. All right, interpret the answer. So this formula gives the amount of time? No, it gives the volume as a function of time, right? Because you have t as your variable, and what comes out is the volume. Let's take a look at this quick solution here. Yeah, they don't really go into it anymore. 4t, here's that, plugging in that 4t. Oh, and that's it. All right, hope that helps.